All right, we got one more example here. In how many ways can 7 students be seated in a row of 7 chairs if Ivanka and Tiffany refuse to sit next to each other? All right, now this looks a lot like the Sasha and Malia problem, right? And I'm actually going to use the result from example 8, which involves Sasha and Malia. In that example, we were looking for how many ways we could arrange the 7 students if Sasha and Malia want to sit, if they have to sit next to each other. Okay, so we already know how many ways there are to arrange people if 2 of them want to sit next to each other. Now, whether it's Ivanka or Tiffany or Malia and Sasha, it doesn't really matter. The names are irrelevant. But if we have 2 people that want to sit next to each other, then we found out in example 8 that there were 1,440 ways to put the 2 people together, where those 2 people have to be together. Now, they could be, it doesn't matter what order they are, right? The 2 people, whether it's Malia Sasha or Sasha Malia, or in this case Ivanka Tiffany or Tiffany Ivanka, doesn't really matter. So that's why we figured out from example 8. Okay, and that's the complement of what we want here, right? Here we don't want Ivanka and Tiffany to sit next to each other. Okay, so the complement of this situation here, where Ivanka and Tiffany refuse to sit next to each other, is we have to have them sitting next to each other. Okay, so what I'm going to do is subtract the complement, and the complement is the result from example 8. All right. Now we want to subtract that from the total number of ways that we could seat these 7 people. So without restrictions, we would have 7 places to put the first person, 6 places to put the next person. We'd have 5 places to put the third, and so on. So 4 times 3 times 2 times 1. Okay. Now if we do that calculation, we get 3,600 ways. Okay. So this is the case with no restrictions. And this is the case where we put, this is the number of ways to put Ivanka and Tiffany together. Okay. All right, so that's the answer to that example. Now, I was gonna one of the things with counting problems is there's oftentimes more than one way to do a problem. So what I want to show you next is an alternate way. This is optional. If you want to stop the video here, you can. But I wanted to show you an alternate way to do this problem if you wanted to count it directly. All right, so in order to count it directly, you would have to break it up into casework. Okay, so let me just show you. I'm just going to write down here, alternate way. Okay, so if you think about where we could put Ivanka and Tiffany in a row of 7 chairs. Now, the key thing here is, okay, let me just kind of draw what those 7 chairs look like. I'm just going to draw blanks. 1, 2, 3, 4, 5, 6, 7. Okay, now if I seat Ivanka in one of these middle seats, like let's say I put Ivanka here, that eliminates 2 chairs next to her where I cannot put Tiffany. All right, so but if I have that same row of 7 chairs and I put Ivanka on an end, either the left end or the right end, then I'm only eliminating 1 chair where Tiffany can't sit. Okay, so that's what I'm going to do. I'm going to break it into 2 cases, depending on whether Ivanka is on an end seat or whether she's in a middle seat. So I'm going to say case 1, and that first case is going to be, oops, just got to spell Ivanka, right? Ivanka is on an end seat. Okay, so we have 2 choices for an end seat. We can either be on the right end or the left end. Okay, so she has 2 choices for places. There are 2 choices for the place where we put Ivanka. Now, depending on where we put Ivanka, we're going to eliminate 1 seat because we don't want Tiffany right next to Ivanka. So that leaves us 5 places to put Tiffany, right? So this is the places to put Tiffany. The choices for Tiffany. This was the number of choices for Ivanka. All right. And then we can just seat the rest of the people. Once we got Ivanka and Tiffany situated, so they're not sitting next to each other, then we've got 5 people left. So 5 times 4 times 3 times 2 times 1 places to put the rest of the people. Okay, which gives us 1,200 ways to seat Ivanka on an end seat and then place Tiffany so that she's not next to Ivanka. All right, so case 2, we're going to call case 2 the case where Ivanka is in a middle seat. So Ivanka in a middle seat. All right, so how many middle seats are there? All right, well, there's 2 ends, right? There's 7 seats. So there are 5 choices for places to put Ivanka. I'm going to scroll up a little bit so I can have a little bit more room to write. All right, so we have 5 places that we could put Ivanka. And then once we put Ivanka in a seat, she's in one of the middle seats, so that eliminates 2 seats next to her. And so then we would have 4 places left to put Tiffany. Okay. And then we have 5 other people, 5 other seats. So we're just going to have 5 places to put the first person, 4 for the next, 3 for the next, 2 for the next, and 1. And when we multiply that all together, I got 2,400. All right. And now we have our 2 cases, Ivanka on the end, Ivanka in the middle. There's only those 2 possibilities. And so all we need to do now is add up all the number of ways. So we have 1,200 ways if Ivanka's on an end, and we would have 2,400 ways to seat them if Ivanka's in a middle seat. So that gives us 3,600 ways, which we like to see that because it matches. It matches what we got before by doing complementary counting. So complementary counting, you can see, is a lot easier. In fact, I used the result from example 8, which made it even easier. But one of the things I like about counting problems is that there are multiple ways to do them, and so you can often check. It's easy to make mistakes with counting problems, and sometimes it's useful to be able to do it 2 different ways, and you have a little more confidence in your answer that way. But so this makes me confident that that's the correct answer because I did it 2 different ways and got the same answer. All right, well, that's enough for that example, and you are ready to begin the discussion questions, and I will see you in class.